guys, let's do another Coulomb's law problem. Determine the distance of separation required for two 1.00 microcoulomb charges to be positioned so that the repulsive force between them is equivalent to the weight on Earth of a 1.00 kilogram mass. Okay, so let's start off by drawing our picture. So I'm going to draw the two charges as two circles or two spheres. Now they're feeling a repulsive force, so I'm going to draw the force arrows and vectors to be pointing away from each other. So these represent FE and FE. Okay, the distance between them is R, and that's what we're looking for in this problem. So we know that the charge on each is 1.00 microcoulombs, so they have the same charge, so I can call each one Q, and Q is equal to 1.00 microcoulombs. Micro is the prefix that means times 10 to the minus 6. So Q is equal to 1.00 times 10 to the minus 6 coulombs. Now, we are going to be using Coulomb's law in this problem because in order to find the distance R, given electric force charges, Coulomb's law is the proper way to go. But at the same time, we're told that determine the distance where the repulsive force is equivalent to the weight on Earth of a 1.00 kilogram mass. Well, weight simply means force of gravity. And because it's on Earth, force of gravity is just Fg equals mg. I don't even need to use the universal gravitational formula. So I know that I need my Fe to equal Fg. So Fe needs to equal mg. So the mass is 1 kilogram. And my g is 9.8 newtons per kilogram. So my kilograms cancel, and I'm left with 9.8 newtons. So my electric force has to have magnitude 9.8 newtons. Okay, so the electric force formula is given by Coulomb's law. Fe is equal to K Q1 Q2 over R squared. Now I'm looking for R, so essentially I need to multiply both sides by R squared, divide both sides by Fe. Or if you want to look at it another way, Fe and R squared are going to switch places. So you're going to get R squared is equal to K Q Q. So notice I've already said that Q1 is Q, Q2 is Q. It's the same magnitude, divided by Fe. Okay, so R, now, I mean, this Q times Q is just Q squared. K Q squared over Fe. So R is equal to the square root of this thing. So times K. K is about 8.99 times 10 to the 9 Newton meters squared per coulomb squared. Remember, this is the electric constant. It's not the constant from Hooke's law, the spring constant, times Q squared. Each Q is 1.00 times 10 to the minus 6 microcoulombs. So times 10 to the 6 coulombs squared divided by 9.8 newtons. Okay, so when you crunch that all in your calculator, oh, sorry guys. When you crunch that into your calculator, you should be getting an R value of 0.030 meters. So that is the distance between the two charges in order for the repulsive force to be equivalent to the weight on Earth of a 1 kilogram mass. So that's it for this video, guys. I hope you enjoyed it. If you did, be sure to smash that like button and subscribe to Physics in the Flesh so you can be alerted every time I post a new video every weekday at 12 noon. Stay tuned tomorrow for video 152, Coulomb's Law 3. Alright guys, that's it for this video. I hope you enjoyed it. If you did, be sure to smash that like button so I know what I'm doing makes sense to you guys. And you know how you can stay tuned for my latest videos? By subscribing to Physics in the Flesh. I post every weekday at 12 noon, and this way you guys can always be the first to know when I post a new video. As always guys, thank you so much for watching. If you missed any of my earlier videos, be sure to click over there on the right. You can click and watch those videos on your screen right now. Anyways guys, Physics in the Flesh out. Whoop, whoop. Holy crap, my nose looks big on camera. I gotta find a new angle.